Now we're going to take a look at some great stretches that can be done along the boards. So the first one to open our hips is an open hip stretch where we put our foot in against the boards and our other foot in against the boards. Our heels are together. We're going to bring our knees together and our hips forward with our shoulders back. And we hold this 10, 20 seconds. We can relax and get out of it and get back into that position. Very important for hockey players to have that open hip for turning and for skating, for striding. From there, we go to a groin stretch. Very common where players put their skate up on the boards and they bend the knee, they stretch that leg. You can do light bouncing. Generally, we don't want to bounce. We want to bring to a stretch and hold. And then from here, we can bring the head down to the knee. You can hold. You should hold for 20 to 30 seconds. Should relax and hold again. Then right there, we can go into a variation where we turn the toe up and we change it from a groin stretch to a hamstring stretch. Again, we can bend the other knee and then bring the head down to the knee. You can try to touch the toe. And we show this again from this other side because it leads us into our next stretch. Right from here then, the player can go into a quad stretch where they just roll their foot along and turn down. And here, you're trying to point the knee in and down. You should feel the stretch right in here on the quad. And you would do this both right and left leg again as well. There's some very simple board stretches we can do. Great for ice hockey. Here we are at Pirani's in Rochester, New York, and I've invited Bob Allen from Maximum Edge Skate Sharpening to teach us all about how we can sharpen the skate better so we can perform better. Thanks for coming today, Bob.
You're welcome.
So we're talking about, Bob has a patented system here that is used by almost some part of Bob's system is used by all of the NHL teams. And he's got a patented blade finishing system and a quick square. So Bob, let me start off by asking you to explain the hollow to us of the blade and what does that mean?
Well, the depth of hollow is put in the bottom of the blade and it's where a groove is cut into the bottom of the blade. The edges should be equal and square to make sure that the level of control for the skater is identical. That hollow comes off of the skate sharpening machine and it can be scribed in 3/8, ½ inch, 5/8, up to any radius that the skater wants.
Is there a hollow that is better per age or level or weight? How does all that work?
Lighter players can use a deeper hollow. But when you get into a heavier player and put them on a deep hollow, you literally stick the person in the ice. It is better to learn to skate on a shallower hollow than a deep one.
And by weight, is there a weight factor?
Oh yeah, the weight is a huge factor because it comes down to the pounds per square inch of a skate blade on the ice. The depth of hollow, if it's real deep, literally sticks you in the ice. And the more weight you have, the deeper you will go into the ice. But then there's also the factor of the contact surface area known as the rocker, contour, or as we call it, profile.
Yes, that's what I was going to ask you. But before we get there, how does that go as far as surfaces? Let's say that that some of the ice surfaces are that you hear of the phrase it's soft ice or it's hard ice. Would we sharpen differently based on being on hard ice or soft ice?
Hard ice, you would want to go to something just a little bit deeper. Soft ice, you definitely have to go to a shallower blade, shallower hollow, depth of hollow, so it'll keep you up on top of the ice.
Okay.
And again, weight has a bearing factor on that.
Great. Now let's talk about this this profile. There's so many vocabulary terms out there now. When we get in there, there's profile, there's contour, there's rocker. What are those similar? Or?
Well, basically those three words all define the exact same thing, which is the shape of the skate blade from the heel to the toe of the blade.
I've heard some numbers out there like this shape is like 9 feet or 10 feet, 11, 13 feet. Is there a
Yes,
range
that's
there?
exactly what it's. The numbers represent the radius, and it's in foot. There are also measurements out there in millimeters, and some people have their own designs along like combination profiles and whatnot. But basically, what comes from the factory is in the foot radius.
Okay, so tell our audience so they would know, what does a radius, what is the length of blade radius, or a profile, as you call it? What does that mean? What does a 9 mean versus an 11 or a 13?
Okay, 9 foot. A 9-foot radius comes off of a 18-foot circle. An 11-foot comes off of a 22-foot circle. So if you took a piece of that circle that long, that's exactly would be the profile or the radius at that point.
And what does that mean? More or less blades on the ice?
The bigger the profile or the bigger the radius, and the longer the contact surface area that the skater is skating on. And that's ideal, especially when you get into heavier players. You want them to be on a longer profile to support their body weight.
So would that be like, if I want longer blade on the ice, so I would skate faster, and maybe shorter blade on the ice so I would be more agile?
That's exactly what takes place. The short blade gives you maneuverability, the long blade gives you speed, but the game of hockey is a combination of maneuverability and speed. Therefore, it's wise to get a blade that works with you and not against you.
Mm-hmm.
So what you would want to do is, depending if it was a small child compared to a 240-pound NHL player, those two people would not skate on the same shape of skate blade.
Okay. Now let's talk about this radius. There's a lot of confusion out there in the industry. Someone says radius, and I'm understanding that it could mean the hollow, or it could mean the length of blade. Mm-hmm. So there should be a difference.
Well, if we could get it to a standard, then one of these days we'd all understand. We would like to be able to call this depth of hollow, mm-hmm, and call this profile. That way there we eliminate the possibility of, yes, they are both come off of radiuses, but it'd be nice to know which radius you're talking about.
So if we said the profile is the length of radius,
correct,
and the hollow is the depth of radius,
that would be ideal.
All right, so we get that defined. And then there's something about, I've heard some things about moving people talk about moving the radius. I understand that's not necessarily what we want to try to mess with.
No, the ideal position on a skate blade is what's called profile center. Profile center is where your center of gravity would actually drop if you dropped a plumb line through while you were standing in your pair of skates, in your stance, with your knees over top of your toes, and that plumb line will go right through profile center. That is the ideal position for so-called the center of the radius, and that we call it profile center. Mm-hmm. If you start playing around with that, you can actually create stress in the body that is unwanted.
We're going to get like hip injuries and different things could come from...
Pretty hard to come down and make actual proof of it, but the results when the skate is in what we call the neutral position and working with the skater, that's when performance actually takes place. Mm-hmm. Do you want to skate on the ice or in the ice? And do you want to be in control of the skate, or do you want the skate controlling you?
Bob, I understand when we talk about the profiling process that even though the skates come from the factory, the blades are not all the same. I've experienced this recently myself. I got a couple blades, and when they actually took them out of the hinges and laid them next to each other, they were different sizes. So you want to comment on this?
The shape of the blade comes from the factory, and I will say this, in the last 2 years the manufacturers have done a better job. But it's an ideal situation is to make sure that the two blades are the same. So to have them profiled, our system is extremely accurate. There are other systems out there whereby they contour or rocker the skate to make sure the two blades are the same. Mm-hmm.
So the important thing is just that we're saying check your blades.
Yes, and the ideal situation there is to be able to put a template on the blade. Our system is a template system whereby we put templates right on the blade, so we make sure they are identical.
Right. So you got to see your local Pirani store, or you got to see your Maximum Edge store.
It's a good idea to come to Maximum Edge, yes.
And there's something else here that we need to look at. I've seen this in working with players, that I noticed that the mounting of this skate, like it's supposed to be on the center here, but sometimes these blades are mounted off. I mean, it comes from the factory, and it's a rare thing, but it's something that...
It's what we call blade alignment.
Blade alignment.
Blade alignment is key to the skater's center of gravity over top of this skate. When the blades are mounted on the bottom of the boots, they're riveted on the bottom, and they're done very fast in a factory, and sometimes the blades are not straight because of the way they're torqued out of shape and the rivets are in the wrong position.
Mm-hmm.
The skate blade, and a quick way of checking it for when you're purchasing a skate, put your thumbs on the side of the skate, and if you look over top of my thumb, you can see there that that blade is mounted dead center between my thumbs. Turn the heel around, do the same thing, thumbs on beside the rivets on the back of the skate, look down the back of that skate, and you'll see that the blade is mounted in the center.
So you're looking down this way for the center, instead of, like, I've noticed sometimes if I look here, maybe this base unit is not quite in the middle, and so this may be in the center, but it looks like it's off center. So
That's
you really
correct.
want to look
what
down.
What you want to do is you want to check the center line of the boot over the heel and the center line of the boot over the toe.
Okay.
This blade is mounted correctly.
So I think there's one more thing that we haven't touched on, and that is pitch. Now there's companies out there making skates with different pitch. When I grew up, I heard of things from Russia. They might put a shimmy underneath the back of the thing to, again, change the pitch. What's going on here?
That's correct. It's actually called a lift in the heel, and that's all well and good if you get a tiny lift put in the heel, but you have to be careful. So the idea of pitch is, and pitch should work with the skater and not against the skater. There are blades on the market today that come with pitch built into them. Also, all the skates come right from the factory, and if you look at this skate here, you can see that the front of the skate is a little bit lower than the back of the skate, or the heel is higher.
Mm-hmm.
All the boots today probably come within 2.5 degrees of all being the same thing. Each company determines the amount of pitch that they want to put in their boot and their holder.
What would more or less pitch give us, so I understand why someone's doing it?
More pitch would take the foot this way, increasing the range of motion in the ankle. Yet if you had heel pitch in the skate would actually be tipped like this, and it would be like skating uphill. You do not want to be skating uphill.
Mm-hmm. So we want the standard that they give us, and then maybe more.
Correct. But that's where it comes down to the skate sharpening and the contouring of the blades. Skates that are sharpened where there is less metal on the heel of the steel compared to on the front of the skate increases what we call heel pitch in the skate. So when it comes to skate sharpening, it's a good idea to find somebody that is good at their skill,
Mm-hmm.
and they maintain the shape of your blade when you finally get the blade to the shape that feels the best for you.
So let's talk about our game. Our game is all about speed. We know that we want more speed, and without giving away all of your secrets right here, right now, I understand that a normal sharpening on a system under high microscope shows that there are actually tears and cuts in the blade, that it's not so smooth. But with your system, you've got a way to make this blade smooth, which means more speed, less resistance. Is that, can you tell us about this?
All of those are absolutely true. The blade is very clean, very smooth. The sharpened edge actually improves blade ice contact. And I have a photomicrograph picture here showing the actual skate blade.
Okay.
You can see here the top photo shows that the blade is almost looks like the surface of the moon. It is burr-ladened on the very top edge, compared to a skate blade that is sharpened and finished using the Maximum Edge system.
It looks smoother here on the bottom, and I understand that sometimes, even though they feel sharp with our finger, there could be a lip created or something.
That's exactly what the machine produces. It produces a rolled edge.
Mm-hmm.
The idea is to reduce that with the sharpening process and to finish it with our finish process.
Is that what a stone did in the past?
The stones actually just turn the steel back in line with the blade.
It rolls it back over, okay.
Yeah, it rolls it back over. Our process is a little bit complicated, but it's actually, once you've learned the process and have the tools, it's actually very easy to accomplish.
Okay. And you want to comment real quick on your quick square?
Yes, the quick square is the tool that we have the patent on, and it's designed to make sure the edges are equal and square. And you can see here this skate has been sharpened. It's only out a square by about 2.5 thousandths of an inch.
Let's show that to the player. So I would never know that if I didn't have a tool like this. Or well, I mean, you'd have to be a trained sharpener to be able to see that.
That's right, but the human eye on average works around 3 thousandths of an inch. But on the other hand, this tool here will actually register 0.5 thousandths of an inch.
It gives you an exact leveling device to tell you. I've heard that said that you could balance a skate when you're done sharpening them. You can just put it on the table and it'll stand straight up.
Balancing only shows you that the skate will balance. It does not show you
if
that,
it's...
Yeah, because if you put more skate lace on one side than the other and it still balances, it means that it's not balanced.
Okay.
This tool reads exactly what's on the bottom of the skate blade. It's the only tool of this nature with this type of accuracy.
Awesome. I can't thank you enough for coming in today and teaching us all about skate sharpening. Thank you.
You're welcome.
In closing, some key points to remember. Never before has there ever been such a DVD like this, showing so many on-ice jumps in such a progression. I have had professional and international coaches alike say that they've seen some of these exercises, but never have they seen all of them in one spot. Players and coaches will now be able to use these exercises to produce the fastest skaters in history. This is probably the truest part of the real definition to the term power skating. I hope that you have enjoyed this DVD. Remember that perfect practice is the key. And practice this progression of exercises. Who knows, maybe we will be watching you or someone that you coached play in the NHL someday.